So let's take a look now at the combined gas law. What the combined gas law does is it gives us a relationship between pressure, volume, and temperature when the number of moles of gas doesn't change. So we can think about a balloon, a closed balloon, or a piston where gas molecules cannot escape or be added, and yet we can change the pressure, volume, and temperature. When we can change all three variables, there is a relationship between the initial condition, pressure times volume divided by temperature, where these are all the initial pressure, volume, and temperature, is equal to the final pressure and the final volume divided by the final temperature. So in a typical combined gas law problem, you'll be given 5 variables and be asked to solve for one of them by using algebra. The one thing we do want to remember, as always, our temperature must be in Kelvin, our volume units need to be the same, and our pressure units need to be the same. So let's look at this example. A sample of gas has an initial volume of 158 milliliters at a pressure of 735 millimeters mercury and a temperature of 34 degrees Celsius. If the gas is compressed to a volume of 108 milliliters and heated to 85 degrees Celsius, what is the final pressure in millimeters of mercury? So the one thing that I want to do is I want to write down everything that I'm given. And I notice that I have initial conditions and final conditions. I also notice that I'm given information about volume, pressure, and temperature. Therefore, I know I'm going to use the combined gas law. Organizing a problem is really a large component of being able to properly solve a problem. So here I have all of my variables listed. I'm asked to find the final pressure. And then I notice that I'm asked to find the pressure in millimeters of mercury. So my pressure units are fine as millimeter of mercuries. I notice that my initial unit for volume is milliliters and my final unit is milliliters, so that's good. These have to be the same. However, even though my temperature units are the same, anytime we use a gas law, our Celsius need to be converted to Kelvin. So let me add 273 to both of these to get my Kelvin units. Okay, now that I have my Kelvin units, now what I'm going to do is I'm going to write down my combined gas law equation, and then I'm just going to plug in all the values that I'm given. So my initial pressure is 735 millimeters of mercury. My initial volume is 158 milliliters. And then my temperature is 307 Kelvin. And that's going to be equal to my unknown pressure multiplied by my volume divided by my final temperature. Okay, now what I'm going to do is I'm just going to multiply these, divide by this, and divide these two. So in my final equation here, I'll just have one number here and then one number here. So my calculator tells me that these numbers boil down to 378, and I'm going to keep my units millimeters of mercury times milliliters divided by Kelvin. And then on this side, my calculator tells me 0.3016 milliliters over Kelvin. Okay, so now I've run out of space here, so I'm going to continue on the next page. Ooh, I forgot something very important on this last equation here. I've got to multiply this by my pressure. Here's my unknown value right here. So let me go to a new slide, rewrite what I've just written, and then we'll do the algebra to solve. Okay, so now I've rewritten my problem, and what I want to do is I want to divide both sides by this factor right here, 0.3016 milliliters over Kelvin. So then I'll know exactly what my pressure is. So I'm going to divide both sides by 0.3016 milliliters over Kelvin. Okay, so on the right-hand side of my equation, this term and that term cancel out, And then on this side of the equation, my milliliters and Kelvin cancel out, and the units I'm left with are millimeters of mercury, which are pressure units. Throughout this chapter, you want to take the extra step to write your units down. Even though it may seem tedious, it really is going to assure you that you're doing the correct math. So now let's divide these values to see what my final answer is. So my calculator tells me 1,253, and that is, whoops, I didn't mean to cross that out. That's going to be my final answer. 1,000, let me write it again, 1,253 millimeters of mercury. And so basically solving this type of equation is plugging in and then solving for your one unknown. When you plug in all your values, you'll have one unknown value multiplied by something else. You divide that value that's being multiplied by your unknown value on both sides to get your final answer.